Hello YouTube, I'm APC. Today I'm making a tutorial for you guys. This tutorial is part 2 of an ongoing tutorial where I'm talking about how to make a prime number generation interface using Swing. So this is what we have so far. We have all the visuals set up, and to continue we are going to make it interactive. Okay, so we have our main method and this set up. Now we're going to move on to this action performed. So action performed will respond to events from the buttons, which the buttons are basically the only things we're going to be listening on. So the way action performed works is, well, this class implements action listener, which means that the analogy I like to use is that we're a spy headquarters. We're like the CIA or something like that, and we gather intelligence. So whenever intelligence is reported to us, it is given to the action perform method in the form of an action event. But as I like to say, we can't gather information without spies. We have to have spies out there listening on things. So we're going to have spies out there listening on things. So right here, I didn't talk about it earlier, but here we're sending on spies. We're saying send a spy to the test button and report back to this object, to the action performed method in this object. So listen on test, report to this object. Listen on list, report back to this object. Listen on clear, and then report back to this object. So that's thrown in here as well to make sure that this is activated at the right times. Alright, so then it's sent back to intelligence agency in form of an action event, and the first thing we're going to decide is where this came from, because we don't have very good bookkeeping. We need to, well, I guess we just need to read the paper and see which spy it came from. So that for that reason we have our object src is going to be the source of the event, and then we have a series of if statements where we're going to do different things depending on which object it came from. So before we go into the logic used here, let me explain to you two other methods. I have set up the print and the print end method, which was what we use to modify the text area, because we're going to be doing it a lot, and I don't want to go through the manual process of changing the thing every single time. So this, when we say print string text, that will add our text string to our text area. The way we do that is first we determine the position on the text area. So well, if there's 5 characters on there now, position will be 5, and then we insert our text at that position. So if we have 5, it'll insert it at the end at 5, and then we print this out to the command prompt. This is only for our purposes, developer purposes, so that we can see in both command prompt and the window so we can verify that's working. And we have print end. Every time we perform an action, we're going to print a bunch of dashes and 2 spaces at the beginning and end, just to make it look all clean. Okay. Now that I've explained those, let's move on here. Here we have process is equal to 1. So we have this process variable to indicate which one of these processes we're working on currently. It's mainly used for this list so that we don't, because the list is the only one that's going to take a really long time. So when list is run, we can ensure that process is equal to 0 before we start running it. That way we don't have overlap with other things. More on that later, but either way, process represents which action we're currently doing. So of course we do initialize up here. We have process, and we also initialize primes. Primes is a class of my making that I'm very proud of, which will help you generate prime numbers. So we don't have to worry about all the logic of how to generate prime numbers. So the way it works is it takes as a parameter the range. So the way the algorithm works is the range is how many primes it's prepared to look for. So if you're prepared to look for 1,000 and you ask it is 5 prime, it'll go with that pretty fast. If it's prepared to look for 1,000,000 and you ask if 5 is prime, it'll still do it pretty fast, but it'll do it slower than it would if it had been prepared to look for 1,000. Because the way it works is, if you ask it whether 5 is prime, it'll move up the list, and every time it finds a new prime number, it'll eliminate all the multiples of that number within this range. So that way it make it easier to find the prime numbers further on. You don't have to understand that. All you need to know is bigger range, more prime numbers you can find, smaller range, less prime numbers, smaller range, faster, bigger range, not as fast. So that's what that means, and 1,000 is just an arbitrary term that I chose. Alright, so that is that. Those these variables. Okay, so in this test, first we're going to create process, and then we're going to read the number from the input area. So, you know, we get the string from it, and then we parse it back into an integer. I've done this before in basic tutorial. You should be able to understand that. So the integer represents which number we're checking, and then we're going to go through this section. So if the length of primes, if the number we input, by default we input 1,000, if the length is less than the number, okay, if the current length of the primes is less than a number, if the number we put in was bigger than the range that the primes has, then we're going to create a new primes object with the given number as the new range. This is a different constructor. It'll use our current object of primes, use the information gathered in that object as a jump start for our current one. So that's what this does, to make sure that we're not looking for numbers above the range. So that's that. And then the fun part is we're going to actually figure out whether it's prime. Lucky for us, test is I already have methods set up in our primes object. So we're going to run that method, and we're going to test that number. If it's true, we're going to print out text area that our number is prime, and then we're going to set our primes found to 1. And if it's not true, we're going to say that number is not prime, and we're going to set our primes found to 0. This is the end of the operation, so we're going to print our end statement and process it back to 0. Alright, so let's go ahead and test that. 100, test. 100 is not prime, which it is divisible by 10, or I guess it's divisible by 2 and 5. Those would be the prime factors of it, 2 and 5. Okay, so then we can try 5, I guess 5, test. 5 is prime, and see 102. No, 102 isn't prime. Let's try that one. Test. So if you like math, you can kind of have fun with this and see how many prime numbers you can find. So let's try something above our range. So by putting in 1,001, it'll notice that's above our range of 1,000, and it should dynamically change it. Let's see if it does that. Yes, it does. So we have to print it out. And notice that if we put in a prime number, and hit test, it'll put primes down to 1, and if it's not a prime number, test, put it 0. Okay, so now we've got our test finished. Let's move on to the next one. List. List is a really long, scary one. Let's not do that one just yet. Clear. Clear isn't too bad at all. All we do in clear is we set the text in our text area to nothing. You can see it right here. If I hit clear, it'll clear all the way. Very easy. Alright, so now we got that one out of the way. We can go head over to list. Before that, I'm going to introduce some new variables to you. Okay. Oh, but by the way, I forgot to say this. The process is 0, 1, or 2, and this is what they are, what the numbers correspond with. And here, okay. So we have this stop variable, which, as I said several times, list can take a long time. So this stop variable represents whether they want to be stopped. If this is set to true, then that process will be stopped. And these are some variables that are kind of involved. I actually don't think I need them, but I'm just leaving them here to be safe because I don't exactly remember how I did this. So, but we'll learn more about those later. So, moving further down, let's go into this. Okay, this doesn't look too bad, but we have a whole nother class that we set up, list. I have it right here that we'll be looking into in addition to this. So let's just get the idea of what's happening. So first set process equal to 2, because 2 corresponds with the list process. We're going to set stop equal to false, because if it was stopped previously, we want to reset it back to false. And we'll create a thread. Thread is a pretty big deal. So what we do is we create a thread here. We start that operation. It's happening in the background. We don't even know what's happening. We don't know what it's doing. We don't care what it's doing, and we move on here. So this will create a background operation happening apart from what we're doing, and then we'll move on from here after that. Let me explain it in a little more detail. So we create a new thread, and then as a parameter, the parameter for thread is something that implements runnable, which, as you can see up here in our list class, we do implement runnable. So it's something that can be run, okay? And in the constructor of list, we put this, which is basically we're giving the list object our contact information so that list can talk back to us and tell us what it found later on if it wanted to. So that's why I put down this as a parameter, which will be more clear when we go into the list class and look at the code there. And we say th.start. th.start will start the thread. It'll start the operations inside this class, and it'll put it in a new thread. That's what it does. Okay, and thread is a fairly complex subject. I'm covering the bare minimums right now. I'll probably make a video just talking about that. So don't be too scared if you find this confusing. Okay, so then we set the text on the list button to stop. So if they hit it again, it will stop the process. So let's say they do hit it again. At this point, process is equal to 2. So when it goes to this switch, it'll go into the 2 case and set stop equal to default true. That's how that works. Now let's go into the list class. You might have gotten a glimpse of it earlier. It's a little bit scary. So here are all the initial variables, and one by one you'll understand what they do. Here's a constructor, not too bad. So we have PG is the prime gen class, and we're just going to set that variable up here. And then this section is where we're going to also grab the primes object of PG, so that way we can work based off the information that PG has already found from previous list actions or from tests and that kind of stuff. Alright, not too bad. Not too bad there. And when you start a thread, when we started a thread, it calls the run method of our runnable class. So this is called when you do that. So let's look at what that does. Alright, so there's quite a bit of stuff happening here, but I'll do my best to kind of break it down for you guys. Okay, so first off, we're getting ready for this thing. We're about to go to a very important soccer game, and we're warming up. We're getting all of our preliminary stuff figured out. So first off, we get the variable. So we're referencing this prime gen object, and we're looking at the input, and we're finding that number. So that's what we're doing here. We're just prepping ourselves, and then we're setting number of primes found to 0. So this will end up being the number that's displayed over here, but we're just have our own variable in this class to keep track of that. And then we're going through the same process as we have test. If the range of primes isn't large enough to meet our needs, we're going to grow it. We're going to set primes.reset, and this requires a little bit of explanation. We have a method in primes called next prime, and what that would say is, so the first time you call that, it will give you 2, next time 3, next time 5, next time 7, and so on and so on and so on. It'll give you the next prime in the list. So we want to reset it. So if we were at 13, we want to reset it back to 2 because we want to output 2 as the first number in our list of primes below given number. So that's why that's reset. And here, referencing the progress object inside our prime gen object, and we're just going to prep that thing a little bit. Okay, so the way progress works is it has a value right here, and it has a maximum. So maximum is the amount of numbers it's working with. So if you tell 500 and its current value is 250, it'll run through the calculations and it'll make the progress bar go halfway and all that. So which is nice because we don't have to manually set the percentage. It will just calculate it based on the numbers that we give it. Okay, so we're checking number of primes below given number. So the given number is the high end, and then the value is the current number we're processing. Okay, and we're setting the string of our progress bar to processing. Okay, all right. So now we finished this section. We're all prepped and ready to go. Now we're gonna begin our process. Okay, so this is gonna be the first iteration of our loop. So we're going. I'll explain why I did it like this in a second. So first we're going to grab a prime. So this will say our prime number will be whatever the next prime is in our list. So we reset it just now, so this will always give us 2 because it was just reset. Okay, and then text, that's going to be the ongoing, this text variable is going to be a string that we're going to keep adding on to, which is going to represent what we want to print out in the text area. So we're going to start off at nothing and then add our prime to it. Okay, and we're going to make number of primes found. We're going to add 1 to it because now we found 1 prime. And then we're going to set prime equal to whatever the next prime in the list is. So we're ready to go for this loop. Okay, now here we have the while loop. So we're looking at while our prime number is less than the number we're trying to reach, which we only want to go that. We don't want to go above it, so that's why this is there. And prime is not equal to -1. If we, for whatever reason, go above our range, like if our range is 1,000 and we look for 1,001 and we didn't change the size, if we look for a number outside the range, the way the prime class is set up is it'll give us -1. So if we're outside of the range, it gives -1, we want to stop as well. This shouldn't happen, but just in case. And not stop. If the user has not stopped this process, we're going to continue with it. Okay? And so to start off with, we go into this loop with a new prime that we need to work with. So we're going to change our ongoing text to whatever the text was, plus a comma, and then a prime. This is why I did this section beforehand, because if we started out like this, we would have a comma, which is improper grammar. We want the comma to go between them, not before them. Okay, then we add another to primes. Our progress is going to be set equal to prime, so this progress is going to end up going back to our progress bar and updating it, and that sets me set equal to our prime number, giving an idea of how far along we are, and then we're going to find a prime number, and then this will iterate every single time. Alright, this is how we, so we have all these variables inside this class, num_primes and num_progress, and we have this text, and you might be wondering, how does this get translated back to our prime gen class? I don't know if you're wondering that, but that's a good question. How does it get transferred back? So we have these variables, and periodically we want to set our text area, set this text area equal to this text variable that we have, and set num_primes equal to the number of primes that we found, and we also want to update this progress bar to show how far we are. So the way I do that is like this. We could every iteration add that to this where we update it. That's not a good idea, because this is running extremely fast. This is going through, however fast the computer can go, several thousand iterations per second, I think. Yeah, that's pretty doable, I think. If we're creating that communication every so often, every so many times, so fast, it'll slow our program down. So we want to do it not that many times. We don't want to be transferring that information 100 times a second. That hundreds of times per second. That would be inefficient. It's kind of like if you're in a job, and this class is performing its job on the side, and we can think of PrimeGen as this class's boss. So it'll be kind of like if this list is doing its job, and every minute it goes to its boss and says, "Look what I've done now. I've completed this section. Look, I've done now. I've completed this section. Look, I've done now. I've completed this section." That would annoy the heck out of the boss, and in addition, this employee will be getting less done. So in order to keep our boss from getting annoyed and keeping this employee efficient, we're going to check on it more periodically, not every single time we are in here. So that's what this section is for. So I have these variables, current time and prep time, and let's see. Okay, first let me talk about current time. So we're setting our current time equal to system.currentTimeMillis. System.currentTimeMillis is a method that you don't have to import anything, just like you don't have to import it or anything. It's just like println, and this will tell you how many milliseconds have passed since January 1st, 1970. They set up the system in January 1st, 1970, and all computers run off this time of how many milliseconds have passed since January 1st, 1970. At the time on your computer is this calculated into a readable time. So we have our time milliseconds, okay? And we just started. We have our previous time adds that time in milliseconds. So we have our previous time, which was created when this program started, and we have our current time. So if the difference between those two is 100 milliseconds, if a tenth of a second has passed since the prep time has been updated, then we want to update it. Update our variables in PrimeGen. So this will still be updating it 10 times a second, which sounds like a lot, but visually you're not going to notice the difference. But it will run a lot faster at 10 times a second. If you want to check even less, you can change this to do every 1,000 milliseconds, every 10,000 milliseconds, etc., etc. But I felt like 100 was pretty good. Okay, so every time we do that, we want to update our PrimeGen, which is a separate method, which I'll go into in a second. And we want to change our previous time to our current time. So previous time represents the previous time that we checked it. Okay. So update PG right here. What I'll do in update, we're going to set the progress value equal to our current progress, so that will update how far along the progress bar is. we want to change the number of primes found equal to the number of primes we have found. Give it an update there. And in addition, our progress bar, we want to put text on there, printing out the percent of the way it made it through. So the way we're going to do that is we're going to create a variable percent, and we're going to set it equal to pg.progress get pg.progress.get percent complete. Get percent complete is a method inside jprogressbar which gives decimal format of how far it is. So we'll give 0.5. So what I do is I multiply that by 100 to put it in percent form, and then when I change the text, I put percent as the percent. So this updates the progress bar. Well, this and this updates the progress bar. This updates the number of primes found, and then we're going to print out our text. So we're going to add the text we found so far to the text in the text area, and then we're going to reset our text, so that way that same text isn't added every single time. And this is very important, we're going to set the stop variable inside this class equal to the stop variable inside our prime gen. So that way, if the user hits stop, we now know about it, and that will update the stop variable in this class right there, and then that will in turn stop this loop if it's still in progress. So that's how that works. And then, okay, so we have this while loop. Once that's finished, either it was stopped by the user or it actually completed its job. After that's over, we want to update PG one more time just to get that extra bit that we, since the last update. And then we're going to update the variables. I don't think this actually matters. I think I could probably take this away, but again, I want to be careful. I want to update the actual variables in prime gen. So that's what I'm doing right here. I'm copying all the variables over. And then if stop is true, if we actually stopped prematurely, then we're going to set the text inside the progress bar to process aborted, and we're going to print out process aborted inside the text area. But if we didn't stop prematurely, then we're going to set the text in the progress bar to finished, and we're going to set the value of progress bar to whatever the maximum is, so that way it'll be completely full. And then we update some other stuff, like the process is now set to 0, and we're going to print out an end, and we're changing the list text back to list instead of stop. So that is all for this program. I hope you understand it, and let's play with it. So also note, this is very important. This is what we're aiming for. This is what we got. So we want our output to look as much as design as possible. So we did a good job there. Okay. All right. Let's see. Let's click list. That went really fast because my algorithm is pretty decent. Like I said in the intro, I spent a lot of time working on it, so it runs pretty fast. So here we just listed out all of the prime numbers below 100. If you ever wanted a list of all the prime numbers below 100, that's it right there. And there are 25 below 100, which we can actually do a little experiment there. So below 100, there are 25% numbers are prime. Let's see, 1,000. How many prime numbers are there below that? 168, so 16.8%. Add another 0. That's 11.56%. Add another 0. 8.9%. Notice that as numbers get bigger, there's less prime numbers. So that's just a pattern that I find interesting because I'm a math major and I'm weird like that. But yeah, that's one of the many patterns of prime numbers, or one of the things about prime numbers is that it's hard to find patterns, and that's one of them that you can find. So we have every time we print one, every time we did another search, it lists them all out just like that. All right, but they all went pretty fast. Let's put a bigger one so that we can kind of get an idea for what's happening here. So let's see, what is this? That is 100,000. Let's try 10 million. So 100,000. That's our 2 zeros. Let's see, 1, 2, 3, 1, 2, 3. Yeah, that's 10 million. Okay, it should give me time to explain it. So you can see that it's going fast still. The percentage that it's moving is updating dynamically, and the number of primes found is also updating as we find more. You can see that the text area is also updating. You can see how it's moving up like that, and if we just try and scroll all the way to the bottom, you can see how new ones are being added. And we can hit stop if we want to stop it early, and you can see how the list thing changes to stop like that. let's clear it and just see how big we can go. This is 100 million. Let's see how long that'll take. Now let's use that's a process aborted. Once this gets to its end, it'll hopefully say finished. Alright, well, while we're waiting for this thing to finish, I guess I'll go ahead and sign you guys off. Thank you so much for watching. I hope that, well, I'm interested to hear about what you guys thought about this technique of going for it as opposed to the other technique of actually going through and typing everything, as I did in the J-option paint tutorial. I'm interested to see which one you guys prefer, because this was a lot shorter. It may not feel like it was a lot shorter, but let's see. I believe this is my 6th recording section, so this will be less than an hour long, and the other one would have been close to 2 hours or over 2 hours long, so 50%. And this was a fairly complex program. This is there's a lot of stuff going into this design, and I talked about threads, and there's all this API for my primes class, and I had talked about. I actually I was planning on uploading the older version, but the original version, but I was like 20 minutes into editing it, and then I just kind of thought to myself, nobody's gonna want to watch this. I'm getting really bored editing this, and probably a lot of you aren't gonna want to watch this either, because it's like an hour long. But alright, this is actually taking quite a bit. 100 million is 10 times bigger than 10 million. It's oftentimes hard to kind of understand that, because it's only adding a 0, but that's actually a lot in terms of making the difference. Fast forward. Actually, I'm impatient. My apology. That's it. Please rate, comment, subscribe. I really appreciate your support. Again, give me feedback on which technique you prefer, me walking through it like this or me typing out everything. And I hope to see you guys in my next tutorial. Talk to you guys later.